Hey everyone, my name is Tamagna-Darr. I'm a Senior Director of Engineering in the Research Org at Tenable. And I'm going to talk to you today about a grounded approach to AI and LLM security. AI again, everywhere I go it's more AI. So a little bit about myself and kind of how I'm coming at this. I've been in vulnerability management for over 16 years, and a lot of what I deal with is everyone panicking about the next big thing and, how are they going to get destroyed by it. Same thing's happened with AI. There's a little more excitement on what it enables, but a lot of panic about what the risks are. First things, AI is not a new thing. It's been around for a while. We've been using machine learning for decades, NLP, things like that. What really changed was generative AI, large language models, and when those became a big thing, that kind of changed for a lot of people. It put it front and center. Everyone started having concerns. What happens if our data is disclosed? What happens when it starts generating malicious code? What happens when AI takes over the world? Everyone had the worst case scenarios. What a lot of organizations are trying to do right now is figure out how do we manage this new risk? How do we enable this? How do we leverage this without it getting, exfiltrating all of our data? How do we make sure our employees are not exfiltrating all of our data? Where do we get started? So, as with all things, OWASP has their helpful top 10, and a lot of these are, look new, but they're not that different. I'm going to focus on a few of them for the talk, but prompt injection, you can think about that a lot like SQL injection. It's same concept, send it a block of text, try and get it to do something that it's not supposed to do. Information disclosure, really what we're looking at there is data that you've put into the AI model going to then get used and exfiltrated, whether that's in a public model or someone managing to prompt inject you and exfiltrate your data. And the other one that I'm really focused on is excessive agency. And this is a really big one because a lot of the risks that come with AI are dependent on what it's allowed to do. If all you have is a chatbot, it might say something that is inappropriate, make you look bad. Maybe it reflects some cross-site scripting code. If you have a application that runs commands on your system, you have a lot more risk. Now, this is not stayed static. Everyone got real excited when LLMs became a big thing. We got to chat with them. We got to ask them to write stories for us and be amazed by what they could do and then disappointed at what they couldn't do. That's kind of where all this started. It put AI front and center for everyone. Before then, it was very much in the domain of data scientists who were building large data sets. This is growing extremely fast, which is one of the challenges we're facing. Every time someone gets up to speed on LLMs, suddenly now they got to learn the next thing. Then they got to learn the next thing. So we started out LLMs. Next thing that really came along was the retrieval augmented generation. So the idea is with traditional LLMs, get a training data set, build the model. That model is static. You get to use it. That's why if you ask ChatGPT about something from this year, it typically responds and says, I don't know anything about that. With RAG now, you can ask questions. The LLMs can go out to an external data source, pull in more data. They can get more context about what's happening. So allows them to stay more up to date. Agentic AI is the kind of current cool thing that everyone's excited about. Build an application. Instead of just having it talk to you and give you an answer and tell you things, now you can have it do things for you, like install a patch on your system, which is terrifying to me. The traditional one people talk about is a travel agent. Instead of the travel agent creating your itinerary, have it book all your flights, have it do all this stuff for you. It's very cool. It's very exciting. Saves us a lot more time and energy from doing the mundane tasks that we don't like doing. But you're also trusting a system and hoping that nothing goes wrong with it. And then most recently, we've seen this new thing, MCP, Model Context Protocols. So the idea with this is to create a standardized protocol so that when you're building a AI application, AI agent, standardized protocols for getting data from external data sources, whether it's a database or a Parquet file or anything else, a protocol that sort of sits in between. That's really great because standardization is very helpful for building applications, can help with security. But we're already seeing this. These MCP protocols are also tied in with servers and services that sort of enable the protocol. And unfortunately, some of these servers have vulnerabilities in them. So now you've introduced another layer of complexity that introduces another layer of risk. Going into some of the specifics, so sensitive information disclosure. This is kind of the first one that everyone got panicked about. What happens when finance uploads the budget and all of your budget data is now part of ChatGPT? What happens if someone puts someone's medical information in because they're trying to figure out what diagnosis to give and all that? One of the areas that's a lot of concern, especially for organizations, is usage of browser extensions. There are a ton of browser extensions. Last I looked on Firefox, there were, depending on how I searched, between 1,000 and 2,000 browser extensions for artificial intelligence, most of them LLM tooling. And the real risk there is if the tool you're using is with a public model, with a public service, there's typically not policies in place that prevent that data from then being used for future training. So it's not like you put that budget spreadsheet in there and suddenly it's available to everyone on the internet, but over time it becomes part of the model, part of the training data set, and could be leaked out in the future. The other angle for information disclosure is prompt injection. So if you're building an application that is using customer data, you've got a ton of cool telemetry, you want to help customers learn from what everyone else is doing, that can be very valuable. But with the right prompt injection, you can get the model to respond with sensitive information based on your customer data. So there's a big concern about information disclosure. Now, prompt injection is the kind of fun, cool one everyone's excited about. And it's actually, there's some people who all they're doing all day is red teaming all the models, and it's crazy what they accomplish. Every time the model is updated to fix it, they break it again. The idea here is to say something to the AI, the large language model, get it to respond with something it's not supposed to. It's essentially social engineering, but with a computer. And we all enjoy social engineering. At the same time, it's, like I said, prompt injection is a lot like a SQL injection attack. You send a command, you get it to do something it's not supposed to, and it responds with some information. Ultimately, you're trying to get it to respond, break the guardrails it has. So a lot of these will have guardrails that say you can't write malware, you can't tell someone how to build a bomb, you can't do all of this stuff. The idea of the prompt injection is to get it to ignore its guardrails and do the thing you want it to do. Now again, kind of going back to that, what capabilities that model has, that's going to depend on how valuable this is and what the risk is. So in the context of a chat application, at best you might get the prompt to respond with some cross-site scripting code, but typically what you'll get out of it is reputational harm. You get the bot to respond and say something inappropriate or talk badly about your company. It's not great, but not the worst thing in the world. As you introduce features like RAG, you get it to start pulling in external data, or if you give it the ability to write some code, test the code, and then bring it back, you're starting to introduce risk. That AI application might execute code, and if an attacker is leveraging that, they might get it to execute code that crashes the entire system or starts putting a backdoor on the server. Then if you think about the agentic AI, where you're actually having a application take actions based on the data it's getting. Let's go with the patching scenario. If an attacker was able to compromise that, which is kind of a worst case scenario, they get the patching agent to install a backdoor. Now, patching agent can do it because it's a trusted system. It has the ability to install that stuff. And if it's compromised enough, you could really take advantage of that. A lot of these are worst case scenarios, still seeing kind of how successful this is. One of the things that I talk about a lot with the teams and customers is, in fact, that it's important to remember, these LLMs, they're probabilistic, not deterministic. So if I do a SQL injection attack and I execute the attack, I get a result back. I know it worked. I got data, it's a database server, it's going to be correct. If you execute a prompt injection, you get it to respond with some data, there's some ways you can validate that it worked, but if what you're after is sensitive data, if you're after social security numbers or credit cards or some other sensitive data, you could get a result back that makes you say, awesome, my prompt injection works, but is that data actually useful? Or is it, as the last speaker said, making a mistake, sending something incorrect? Now, yes, there's value in proving out that you successfully completed prompt injection. You got to respond with a string that looks bad, but is that useful? And keep in mind, most attackers are looking to get something out of an attack. Some are at it for fun, but if you can't reliably get something back, it's not going to be as useful. So, we've tested out some of this. So we've tested out some various prompts. We tried to get customer IDs out of an application that was written. And we were actually able to talk enough to the prompt, and it gave us a customer ID. And I was talking with our team that did it. We got into it, we were looking at it, and it responded with a string that looked like a customer ID, but it was just a random string. It had nothing to do with that customer. So in that context, it's great. You've proven that it can be prompt injected, but if your goal is to get something useful out of that system, it's not going to be very helpful as an attacker as a traditional SQL injection attack where you know what you got. Now, excessive agency, again, this is kind of what it's getting at. This is really going to control how bad the attack is, what you're going to get out of it. And when you're building applications, one of the things you want to be really mindful of is how much freedom do you want to give it. Now, there's this kind of ideal state where AI can do everything for us and we just talk to it and it does everything and we never have to do anything again. But that means someone else can trick it. So whether it's building a chat service or building a agent or anything in between, you want to limit that to as little capability as possible. One of the ways I've seen a lot of the prompt injections is people just have this wall of text, 5,000 words long. Realistically, practical use case, you probably don't need that from any customer. So a lot of this is about limiting what people can do with the AI and what you're going to let it do. If you don't need it to install patches, don't let it install patches. If you need to let it install patches, give it a very specific set and a very specific location where it can pull them from. You're going to limit the amount of impact that you can get out of it. Now, these are kind of the risks that a lot of people are focused on is how can you get the LLMs, the AI, to do something incorrect. But what we've seen a lot of is people getting overly focused on the underlying tool. Everyone's excited about these things. Everyone's excited about breaking them. It's really cool to break them. Everyone's kind of losing sight of all of the infrastructure that goes underneath them, all of the libraries, all of the services, everything that's part of it. And some of the research we've done, we're looking at a feature from Microsoft that part of the chat client pulled data in from third-party connectors, so it could reach out to connectors, and they did a good job. They had limits, so it was built on Microsoft Azure. It wasn't allowed to connect to internal services, all of that. So they put good filtering in. But after doing some more research, our team found that you could use 301 redirects to bypass all of those mitigations. So we didn't break the AI, we just broke the underlying infrastructure and bypassed all of the protections. That's going to be very attractive for an attacker because, again, when you get that to work, it reliably works. It's deterministic, it worked. If you break the AI, maybe you broke it. So anytime you're working with this, whether it's installing applications or building out your services, you really want to focus on the underlying infrastructure. Make sure that is very secure. And the advantage there is that's something we're all more familiar with. AI, we're still getting our heads around, but securing infrastructure is something that we've got practice on. So there's a lot about the challenges, but some of the things we can do to kind of better prepare and better protect our infrastructure. Number one thing I tell people when I talk to them, just know what's in your environment. That's the best thing you can do. And the challenge again is who's installing browser extensions on their laptop? Who's controlling that? Are people installing random extensions? Are they using open models? What applications are in use? Are you the products that you're purchasing, do they have AI features? Are those enabled by default? What's the capabilities of those features? If your teams are building AI products, if they're building AI-enabled features, understand what the limitations are, understand the infrastructure and the libraries they're building, also the models they're using. Are your teams using models that you have a contract with, or are they using open models, in which case a lot of that is going to go into the training model in the future? You want to have a lot of controls around that and understanding what it all is. And then take basic steps. So again, know your inventory, understand what you have, understand what people are using and what people are building. When you're building the applications, make sure you have controls over what's being used, what infrastructure, what models, what capabilities are you giving it? Are you going to let it just chat? Are you going to let it pull in data from third-party sources, internal sources, all of that? Make sure that there's limited agency on what the product can do, what the feature can do. And then establish strong policies. So the inventory is great, but if you don't have policies in place that tells everyone, you can use ChatGPT, but not this. You can use Gemini, but not ChatGPT. If you don't have policies, people are going to end up doing whatever they do. You'll have an inventory of stuff and nothing to do with it. Much like a lot of companies will have specific software that they allow to be installed, we should all have policies. These are the browser extension capabilities that we've authorized. We've done the evaluation. We trust the model. You can use this. You can't use this. It's the first line of defense against this stuff. It ensures you've got at least control over what's happening. And if people use something that's against policy, you at least have something to say, look, we're not allowed to use this. You have to go use this. You want to have some flexibility because some of the models, if someone's developing something and not using sensitive data, but they're learning, you want to have ways that people can do that. But having good best practices is really critical. Any questions? Thank you.